Alright, so when we left off yesterday, we were doing this one problem, guys. We were doing this problem, a free response problem. And I told you that for your homework, you should try it on your own. And how did you guys do?
It was so hard.
It was so hard. Okay, so let's go ahead and go through it and see how we do. So we talked about A. So we found G of 3. Did you guys find G of -2?
Yes.
Okay, so you did, let me add a new page. Okay, so I would do from -2 to 0. Was it G prime on the graph? Yeah, G prime. That's going to be the same as G of 0 minus G of -2. Okay, and we know G of 0, so G of 0 was 5. So that's 5 minus G of -2. All right, when we represent the -2 to 0 of G prime of x dx, that is the area under the curve G prime of x from -2 to 0. So that's right here. Now that's very similar to an area we've already found, right? So that was our 1/4 of the circle, 1/4 pi r squared. So it's just pi. Subtract the 5 over. Divide by negative, so it's really 5 minus pi then. Okay, that's what G of -2 is. Did you all get that? Good. All right, so let's try B. So B says find the x-coordinate of each point of inflection on the graph of G of x. Okay, we don't have the graph of G of x. Okay, so let's think through this. Point of inflection, what does that mean? Second derivative equals 0, right? But what also has to happen for a point of inflection? It has to change. Like your second derivative has to change from like positive to negative or negative to positive. Okay, so we need to look at our, this is the graph of G prime. So what are we trying to find on the graph of G prime? What are we looking for? Not concavity, because this is G prime. So the slope, right? Does that make sense? Because we're trying to find G double prime, which would be the slope of G prime. Okay, so we're looking at the slope. So basically, if I had done a little chart for G double prime, I'm talking about the slope of this. So until we get to -2, so between -7 and -2, my slope is positive, right? Okay, then my slope is still positive here, right? So my slope is still positive until 0. And then all of a sudden at 0, my slope becomes negative. Okay, then it's positive at 2. Well, from 2 to 3 it looks like. And then it's negative, right? The slope is negative here. So if negative from 3 to 5. Okay, so I kind of drew out the chart that you're familiar with. So this means we're concave up, down, up, down.
Wait, but how can we do that if the graph is just G prime?
Because we're looking at the slope of G prime, right? We're not looking at the concavity of G prime. We're looking at the slope. So we're looking at the first derivative of G prime, which is G double prime.
So for the explanation, do we have to give the rationale, like why because of the change in slope?
Yep, you cannot just draw the chart. Remember, they don't grade the chart at all. So you actually have to write out. So the question was, find the point of inflection. So a point of inflection would be at 0, at 2, and at 3. That's when it changed from concave up to concave down, then from concave down to concave up, and then from concave up to concave down. Okay, so on your explanation, you need to say something like, in order to find a point of inflection, I looked at G double prime, which is the slope of G prime. You could say something like that. and the slope of G prime changed from positive to negative here, negative to positive here, positive to negative here. Therefore, there are points of inflection at 0, 2, and 3. A lot of people will simplify it and they'll just say there was a change in sign at these locations, which is fine, as long as you're saying there's a change in sign of G double prime, right? Or the slope of G prime. Make sense? Okay, and then C, it says the function h is defined by h of x equals g of x minus 1/2 x squared. So h of x equals okay, it says find the x-coordinate of each critical point of h between -7 and 5 and classify each critical point as a local min, relative min, a relative max, or neither a max or min. Explain the reasoning. Okay, so basically we want to know when h prime of x is equal to 0, right? So h prime of x would be g prime of x minus 2 goes to the front, so x. We want to find when it's equal to 0. Oh. So in other words, we're finding when x equals g prime of x. So on our graph, what does that mean? So x equals g prime of x. Yeah, points like 1, 1, right? So there's one right here. I think there'd probably also be another one. Yeah, right around here. So how'd you get that?
Well, because since it's a perfect circle,
Mm-hmm.
can you assume that? Did it state that anywhere or not?
It's a perfect circle.
Okay. Yeah. Yep. And then so that would mean that they're the radius being 2.
Mm-hmm.
Then that would be the square root of 2.
Yep, that's exactly right. So basically, if you had the unit circle, so 1, this point right here would be square root of 2 over 2 and square root of 2 over 2, right? X and Y. But this isn't radius of 1, it's a radius of 2. So it ends up being square root of 2, square root of 2. Okay, we could also solve that. You could solve it, where'd my page go? Like, that's the circle x squared plus y squared equals 2 squared. Do you guys agree? Centered at 0, 0, radius is 2. And you're saying when is the x value equal to the y value on the graph? So you could say x squared plus x squared equals 4. So 2x squared equals 4. So x squared equals 2. So x equals the square root of 2. Plus or minus. So shouldn't we also have this one too? So we have 2 places.
Even though it's a
Oh yeah, that's right. You're right. Yeah, because it's going to be the same. You're right. Y'all are. So I'll give Grant the points. He said it the loudest. All right. Yeah. So that one wouldn't work because 1 would be plus and minus. Okay. So are there any other points? I don't think so. Yeah. I think that's the only 2. Okay, and then you have to classify each one as a relative max or min. So you'd have, we said 3 and square root of 2. Oops. And this, we're talking about h prime. So if I plug in 0, g of 0 minus 0. So what is g of 0? Oh, we don't. Oh yeah, g of 0 is 5, right? So it'd be positive. So you could do like a little chart like this. I don't know if this will work though on the other ones because we don't. Oh wait, yeah, I'm using the wrong thing. This g prime of. So I need g prime of 0, which we do know is 2. So this would be 2 minus 0, so it's 2, so it's positive. See what I'm doing? So then maybe plug in 2. So if I have g prime of 2 minus 2, g prime of 2 is 0, so minus 2 would be a negative number. And then if I try like 4, 4 is, something positive, so like around 1 maybe. You could actually find it. I mean, that is a line segment. But then subtracting out 4 would be negative. Is that right? Negative. Okay, and of course you can't just leave the chart. You need to explain it. But there would be it goes from positive to negative. So there'd be a relative max here. What else do you need to check? Endpoints. But in this case, it looks like it was on an open interval. They just said between -7 and 5, not inclusive. See how there's no less than or equal to, so we don't have to check the endpoints on this. Okay? All right. Did anybody get all of that right? No. Someday it's just all going to click. You're going to be like, oh, I get it. We still have another semester. So.
When will this take?
Soon. All right. So if you look at the scoring guide, you can see the different ways you get points. So for part A, using the fact that g of 0 equals 5 for both parts, finding g of 3, finding g of -2. Part B, identifying 0, 2, and 3 as the different places. What were we doing on B? I can't remember. The different places that there was a point of inflection. And then the explanation for that. And then the last one, finding h prime of x correctly, which I think all of you could get a point for that, right? That wasn't hard. Identifying the 2 places, so square root of 2 and 3. So some of you guys might have missed the square root of 2, I think, but you would have all gotten the 3, I would think. Showing the answer of square root of 2 with analysis and showing the answer of 3 with analysis. Make sense? Okay. All right, you ready for the next one? Now, did you guys feel good about this one on your homework? Yeah, because it's very similar to one we did yesterday, right? Yeah. Okay.
And I know how to play my calculator.
You know how to use Math 9, so. All right, so the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t equals 1,380 t squared minus 675 t cubed between 0 and 2 hours. They always have these, where there's people entering an amusement park, a rock concert, things like that. So r of t is measured in people per hour. No one is in the auditorium at time t equals 0. Why is that important? If we were integrating and there were already like 100 people in there, you would have to use that initial condition, right? So you'd need to use that in your, like from 0 to 5 or whatever, you'd need to use that initial condition. Okay, the doors close and the concert begins at time t equals 2. So question A, how many people are in the auditorium when the concert begins? So how did you guys find that? Integrate from 0 to 2, exactly. So that's what Grant was saying. I think that he knew how to use his calculator. So go ahead and put that function in for y1. Okay, and you want to be careful on your AP test because you could like leave off the 5 or something and write 67 t cubed and you would not get it correct. So the easiest way to write this is 0 to 2 r of t dt. And you would get full points for that setup. Okay, if you're a perfectionist and you really want to write it out, you can. You can do 0 to 2, but do it in the next step. So at least write that easy part first. Okay, so let's put it in for y1. And we're going to leave it as y1 throughout the problem because we're going to use it later. Do you guys remember how to get y1 so you guys can do like the Math 9, so it will come up as definite integral. Yeah, so you go to vars, so do Math 9, hit vars, so variables. We want the y variable, so arrow over to y vars. It's underneath the arrows.
Wait, what do you click to get to bars?
The button says vars on it.
Oh, bars.
And then you arrow over to y bars and then hit y1. So that's pulling up your whole thing that you put into y1. So it's very convenient if you put it into y1. Your x value, so comma x, goes from 0, comma to 2. So it should look like y1, comma x, comma 0, comma 2. Some of your fancy calculators actually do this now, where you put in 0, 2, and then you have to do dx. The x is telling you what you're taking what variable you're integrating. Okay, you guys should get 980. Use correct units. What are the units? People. What I always had to think when I was in calculus is I had to think about the graph. I'm a very visual person, so I thought, okay, my R of t is in people per hour, and my time is in hours. So if I'm talking about the area, which is what an integration sign means, then I'm talking about people per hour times hours, right? Length times width, which is people. So you can think of it that way if you get confused. You got error? Okay. All right, B. So you said B was pretty easy? So find the time when the rate at which people enter the auditorium is a maximum. Justify your answer. So how do you find when the rate is a maximum? Take the derivative, set it equal to 0. So you're going to do r prime of t equals 0. Again, you're getting full points for the setup when you just write that. Okay, now in the next line, you can take the derivative if you really want. Or if this is a calculator problem, which it is, what can you do? What?
Math 8.
Math 8, right, in deriv. Okay, so, no, I can't hear. Okay, so under our y equals, let's go to y2. And we're going to do math 8. So in deriv. We want to take the derivative of y1. So I'm going to go to variables, y variables, function, y1. And it's going to be x comma x. So on my y2, I have this. In deriv y1 comma x comma x. Oh, this is y2 actually. It's saying you're taking the derivative with respect to x, and you're going to plot all of the different x values. Okay. And we want to find when it's equal to 0, so I just want to highlight y2. That's the only thing I want to graph, and I'm going to graph, and I'm going to find where it crosses the axis. So I'm finding the 0. Ooh, my numbers are not very nice. Okay, I got 1.363. So what you guys got? Okay.
I did it like at home. I did it without using my calculator. I got 1.362.
Okay, you can round or truncate, so that's fine. So it was 1.3629 something. So that's truncating or rounding. Okay. It says justify your answer. So that kind of gives you a clue that this could be a maximum or a minimum, right? So you need to consider if it's a maximum or minimum. So you can do your chart, but what is also helpful about this one is we have a closed interval, 0 to 2. So what's happening is it's either starting at and going like that, or it's doing something like that. I mean, these don't necessarily have to be the same, but I would just check the endpoints. So let's check the endpoints. So let's do R of 1.363. And let's go ahead and store that number. Do you guys still have it on your screen? So I'm going to store, so I'm going to hit X on my main screen, and then I'm going to store it as A. I'm writing myself a note. My window wasn't good, but I still got it. Just do your normal like zoom 6, your standard window, and you should get it. It looked like a straight line on mine. Did it look like a straight line on yours? Yeah. And then look at your y values. The y values kind of give you a clue if you're above the axis or below the axis, right? Positive or negative. Okay, so I want to put this x value I found into my r function. So what's the easiest way to do that? Table. So go to your table. Make sure you have y1 highlighted again. And you want to put that x value in so you can do alpha a if you stored it, or you could actually probably still do x. Some of you guys probably still have it in x. So when I do that, I get, I'm going to arrow over, 854.527. And then I'm also going to try the endpoint. So I'm going to try r of 0 and r of 2. R of 0 is 0. R of 2 is 120. Okay, so now it's clear that that's a maximum. From those endpoints, you went up, right? So it's a maximum.
I don't see how we found our.
How we found the 1.363? Use the 0 function. So do second trace 0. And then, yeah. And you can kind of tell by your y values if you're above or below the axis. Yeah, I mean, you could always zoom in on that area too. That might help. But okay. All right, so good so far? So you would need to say something like, after checking the endpoints, it is clear that this is a maximum or something. This is the maximum. Okay, so C, the total wait time for all people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. So they're talking about the total wait time for all the people. So adding up, you know, if Roshni waited 2 hours and Rachel only waited 45 minutes, adding those together for the total. All right, the function W models the total wait time for all people who enter the auditorium before time t. The derivative of W is given, so we have that. Find W2 minus W1, which is the total wait time for those who enter after 1 hour. Okay, so how do I find W2 minus W1? All I have is W prime. So what can I do? Dana? Integrate from 1 to 2. That's right. So you're going to integrate from 1 to 2 of W prime of t. Remember, write it the easiest way possible, W prime of t. That finds you W of 2 minus W of 1. That finds you what you want. Make sense? So that means that I'm integrating 1 to 2. 2 minus t times r of t dt. So if I was putting this into my calculator, I already have r of t for y1, right? So I would do math 9, so it would look like fn int. I'm just writing this for you guys, you don't have to write this. 2 minus x, y1, comma, x, comma, 1, comma, 2. I would do that. So math 9. You got that part? All right. See? Told you someday it's just going to be click. I mean, not all of them.
Let's slow down.
I think, 60% of the AP questions, I think you'll know when you look at them. And then the 40% you're going to freak out about until you get your scores. It happens. I told you I didn't even know who Riemann was, and they asked me for a right-hand Riemann approximation. And I was like, what is that? My teacher had never used that word, so. What?
Stats.
Stats was rough.
The philosophy of stats.
All right, so what are my units for part C? Units? Hours. Again, this is the total Someone didn't wait 387.5 hours to see someone in concert.
I would.
Who's the one that's playing tonight downtown? The Poison guy. Brett Michaels is playing downtown. Don't wait 387 hours to see Brett Michaels.
There's like 60 concerts next week.
Yeah, it's free.
I'll buy it.
All right, D.
God, 60 days.
All right, so on average, all right, here we go. On average, how long does a person wait in the auditorium for the concert to begin? Okay, it says consider all people who enter the auditorium after the doors open, so from time 0 to time 2, and use the model for the total wait time from part C. So you're kind of using some similar information from before from part C. So now what do? Do we already know how many people entered during that time?
980.
Oh, we do, 980. So what do we need to do now? I'm all excited.
Divided by the hours.
Well, how do we find that total wait time from 0 to 2?
We already have.
We only have from 1 to 2.
Oh. Don't do it again.
Don't double it.
Do it again.
Do it again from 0 to 2. So we're going to do it from 0 to 2. So basically we're going to take 1 over 980 times, I mean, you don't have to write it that way. You could just say divided by 980. We want to find W2 minus W0, right? So this is the total hours divided by the people, the number of people that enter during that time from part A. All right, so I have 1 over 980. I'm going to integrate from 0 to 2, W prime of t dt. Okay, if you're a good student, you still have that in your calculator, and you know that you can hit second enter, and you pull up your last entry. You scroll and you change the 1 to a 0. Did you guys seriously not know that till I just said that? Oh, Lord. So you get 760. So it's 1 over 980 times 760. So you get 0.776 or 775 if you truncate. Hi. What are my units? Hours per person, right.
Do we have to put it in terms of like minutes?
Nope. I don't think it said minutes, right? Yep. So that's fine. They really wanted to see that Brett Michael concert. Waited almost an hour.
I don't think it's worth it.
It is free. All right. So you feeling better? You like those? Okay. They always have these questions where they relate the slope, right, to the area. So all these problems will relate to different things. Okay. All right. Different points. You guys can kind of see the different points. Yes.
If you get A wrong, then you answer that you got A, D.
Oh, good question. Okay, if you get A wrong, so let's say you got 970 people for A, and then you use that in D, they will still give you points for the correct setup if you use that number from A. So let's say you could not get A at all. You had no idea. Write down a number. Write down 5. It wouldn't be 5 people. I mean, write down one maybe makes sense. 1,000 people. And then use that number, and you'll get the setup correct for your part D. You won't end up getting the answer point, but you'll get the setup at least. All right. Okay. Did you guys try this one? Or was this? No, you didn't try this one? Okay, let f be a function that's twice differentiable for all real numbers. The table above gives values of f for selected points in the closed interval. I always hated table ones. Do you guys not like table ones? I didn't like these. They're not bad. Okay, so it says estimate f prime of 4, show the work that leads to your answer. All of you should get this. It's not hard.
Wait, I did not do that.
What should you do? Come on, Grant.
Should we integrate?
No. No integration.
If you don't know the answer.
Thank you, Victoria. Victoria saved the day. F of 5 minus.
Every time. Oh, that
You're not integrating because you're looking for the derivative, right? F prime. So that involves slope. All right, so you end up with -2 minus 4 all over 2, so -3. So you get a point for this because you've shown the work that leads to the answer. All right, B. Okay, evaluate 2 to 13, 3 minus 5, f prime of x, dx. This one, again, is not too bad. So, Amber, what do you think I do? Huh? Oh, you're still doing that? Mackenzie, what do I do? What if it had been 3 minus 5x squared? Yeah, you could bring it into each piece, or you could just actually integrate from there. Yeah? So if I integrate, you guys can all do this. It's not hard. If you integrate, you should get 3x minus 5 times f of x. And this whole thing is going to go from 2 to 13. Right? Did I lose you?
No.
Okay, you're still with me. All right. Plug in 13. So I get 3 times 13 minus 5 times f of 13. That's the first piece. Minus, plug in 2. 3 times 2 minus 5 times f of 2. So I get 39 minus 5 times f of 13. Well, f of 13 is in our chart. It's 6, so 30. Minus 6 minus 5 times f of 2. F of 2 is 1, so 5. So you end up with 9 minus 1, so 8. Still feeling good about this? All right, I think you can also feel good about the next one. I don't think it's too bad. C. So it says use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 f of x dx. Show the work that leads to your answer. So you could sketch it if you need to. Are you guys getting to the point where you can actually do this without the sketch? No? So let's write the widths of the rectangles on the top. So this first rectangle, if I'm doing a left Riemann sum, I'm using the left point and I'm going to go over to the next one. I'm going to use the left one and go over. Left one and go over. Left one and go over. Okay, so I'm using this width here is 1 from 2 to 3, right? The next width is from 3 to 5, so it's 2. The next width is from 5 to 8, so it's 3. And be careful, the next width is not 4, 5. Okay, so those are the widths of the rectangle. What height do I use for the first one?
F of each one.
1. I use the height of 1, right? It's f of 2, which is 1. It's this height. What height do I use for the second one? 4. Then -2, then 3. Notice I stop at 3. The other one would be the right endpoint of that rectangle. Okay, so I have a width of 1 times 1, plus a width of 2 times 4, plus a width of 3 times -2, plus a width of 5 times 3. I think that's enough for your setup. That shows your. So you get 1 plus 8 minus 6 plus 15. 18? We still good? Yeah. This is a question 5.
I really like this question.
A question 5. That should be one of the hard ones. We're feeling good about this. All right. Now here's the one that got my student in 2009. I was one student in 2009. It was kind of sad. I wasn't here. One student in my class. All right, so she had trouble because she forgot what the secant was. You guys remember a secant line? Okay. So let's go ahead and sketch this one out. D. So it says suppose f prime of 5 is 3 and f double prime of x is less than 0. for all x in the closed interval. So what does that mean? F double prime is less than 0. Oh, is it time already? It means it's concave down. Okay, right? Concave down. So when you draw your curve, it looks something like that. So that basically at 5, so let's say that's at 5, your slope is 3. And then it's concave down. Okay, it says use the line tangent to the graph at 5 to show that f of 7, so f of 7's over here, is less than 4. So on the curve, that's where f of 7 would be. You need to show it's less than 4. Basically, if you use the slope, you're going to get that it's less than 4. I guess I'm going to have to continue this one later. I'll keep my sketch for next time. For now, there's no way I can explain it in 10 seconds.
Darn e-schedules, man. 5 minutes makes such a difference.
All right, you guys are lucky with no homework. I mean, you can try that one if you haven't tried it. But